Hey, we're back with collections, and these are arrays and vectors, and these are awesome. These are ADTs, or abstract data types, and we call these collectors, and we're able to store. They're just great. We can store a single data type, but multiple items in one single variable, and that's an array and a vector. And one of them is size, and the other one can be whatever size we want. It can expand and contract. So let's get into this because these are a lot. You understand these, and you're moving to the front of the class. So let's go. Okay, what are arrays? Arrays are a collection of elements of the same data type. They provide a way to store multiple values of the same data type. That's it, same data type. Now, an array has a fixed data size. It allocates memory just like we did with our variables, right? So we took a variable integer and it took 4 bytes of memory, a continuous little byte of memory. Now an array takes a continuous block of memory depending on the size that we make it. And once that is determined, it can't be changed. We can't resize the array. So here we go. So how do we declare an array? Well, we declare it like it's a variable, because what does an array do? Array holds variables. So data type, we know that. Data type, name, and then the size. Okay? So this is an integer array. It holds only integers. The name of the integer array is numbers. And it holds 5 numbers. Now, here's what's special about arrays. Just like, let's say we declare a variable, an int variable, same rules, an int variable called dogs. That's a G. So we do dogs, right? That's how we declare a variable called dogs that is an integer. Make it an array, we're just going to give it a square bracket and tell it how many dogs we want. I think 3 is a good number of dogs. Okay? Once we do that, that doesn't look like dogs. But anyways, let's not waste time on that. Once we do that, the compiler, when we hit run or debug, our compiler, it goes out into memory and it says, okay, integers are 4 bytes. And I have 5. So 5 times 4 is 20. I'm going to grab a block of memory 20 bytes long. And I'm going to section it off every 4 bytes. And we start counting at 0. So there we go. So the array, this is continuous memory, right? And that's how the array is built in the compiler at compile time. And we're going to go over some more stuff on this because we're not done yet. Notice we start counting at 0, okay? In arrays, or in our container classes, our very first index is 0. All right? That'll come into the play when we do our for loop and we start I at 0. Okay, arrays can be initialized during declaration or afterwards. The most important thing is we need to give them a size. If we don't give them a size, then we can't have an array. We'll throw a thing. But if you wanted to give them value, you can say data type, name, it's an array of size 5, and it's going to have these values in each index. 1, 2, 3, 4, 5. So we can go ahead and initialize it at declaration, which is good. Or you can initialize it, and then you can populate it, right? Index 0 equals 1, index 1 equals 2, index 2 equals 3, index 3 equals 4, index 4 equals 5. The size of this array is 5, but the index go from 0, 1, 2, 3, 4. That's 5. Right? Okay. So that's our array. That's how we declare an array. Now this is just declaring an array. There's a lot more to do with arrays. But we got to be able to build it before we can play with it. Because you can't go out of bounds, segmentation faults, all sorts of nasty things. Good traps. Elements in the array can be accessed using indices. This would be my indice. Okay? So 0 accesses the first element. An indice starts from 0 to size minus 1. Remember, our number array was size 5. So our very last element is going to be size minus 1. So 5 minus 1, so our element is 4. 0, 1, 2, 3, 4. All right, those are our indices. That's our index right there. Arrays have a fixed size, which cannot be changed during runtime, so they're not dynamically resizable. So during runtime, we can't do anything with it. Like I said, it allocates a continuous block of memory, and then it indexes it 0, 1, 2, 3, 4. Each one of these block of memory will hold an integer. If you try and go beyond it, let's say you said numbers and put bracket 5 there, it would be in unallocated memory space, and it would give you an error. Okay, it would give you an error, and we'll see what the error looks like when we do our code. It's easier to see what's going on. All right, so the arrays are fixed size. Just remember, arrays are fixed size. Now, let's say you're going to write a program, but you don't know, you're like, I want to use a container, but I don't know how many objects I'm going to have. Right? I mean, it's not fixed size. I need something that can expand and contract. Well, we're going to use a vector. And a vector is part of the STL, or standard template library. So the vector, it's smarter than the array, right? Arrays are powerful, but they're dumb. Like, think football. Vectors are really smart, and they're expandable, and they're really, really pliable. So you can just declare a vector and then be like, man, I'm just going to keep adding stuff to my vector. I don't know if I'm going to go over 5 numbers or if I'm going to have 50 numbers. So I'm going to use a vector. So it provides the dynamic array-like container with resizing capabilities, and this is what we call linked list. Vectors can grow and shrink during runtime, and that's what's really cool, because it's not a continuous block of memory. The vector gets declared and it just grabs a block. And it says, okay, I'm an integer or a string or a double vector. It doesn't matter. I'm just a vector of some data type. And I'm just going to start here. And if you want to add stuff to me, man, go ahead. I'll find the first memory location, and I'll just, remember we talked about pointers and reference? I'll just refer to that. And then I'll just create this chain. Every time you add somebody to me, I'll just create this chain of value. And so it doesn't matter. I'm not, allocating a continuous block of memory. I'm just allocating when I need it. So vectors are pretty cool. It's a templatized array. We'll see that in our when we see how to do it. So to use a vector, we have to bring in a new library. Now we already have the IO stream. Remember, pound includes. That's a compiler directive. It goes go find the IO stream library. Well, we're going to use the pound include. That's a keyword for us. And then we're going to take our carrots, and in the carrots we're going to say we want you to get the vector library. This pound include goes above your header files as we see it, and you can put it above the using namespace std, or you can put it wherever you want. Just don't put it in a method or anything. And it says, hey, go find the vector library. And the compiler goes, oh, we found the vector library. And it's like, yeah, we can use vectors now. And then we have the ability to now declare a vector. Okay, so how do we declare a vector? Well, it's a little bit different, but a vector has a keyword vector, and then you're going to give it the data type. So this is just like declaring a variable. An array is just a variable that can hold multiple of the same data types. A vector is a variable that you can just hold, a data type that you can hold multiple of the same data type. So we have to use the keyword vector. What do we want our vector to hold? A vector can hold vectors, a vector can hold objects, a vector can hold any data type we have. A vector can hold that data type. And then what do? Well, we name it. So keyword vector, carrots, because it's a template. And then what is your data type you want? And then go ahead and give it a name. Okay. You can initialize these just like we did the arrays. You can do it like right here, uninitialized, just declare the vector as an integer vector. Or you can say, you know what, I know the starting numbers of my vector are going to be 1, 2, 3, 4, and 5. So I'm just going to build it 1, 2, 3, 4, and 5. This doesn't mean that it's only size 5, because we can add and subtract to it. We can delete from it. We can add to it. We can delete, add. We can keep adding. We can make it big. We can make it small. And the cool thing is vectors know their size. We'll talk about size when we get to the coding example. The difference between the methods that are attached to a library and one that aren't attached to a library. So vector functions, how do I put value into a vector? Well, we saw how to put value into an array, right? Now we just use the equal sign, right? Numbers at index 0 equals 1. Vectors have functions inside the library, and we're allowed to use these functions by using a delimiter and then the function. So we have, these are our most simple ones, right? Pushback means add an element to the end of the vector or append. Popback removes the element of the vector, which is pretty cool. And then size returns the number of elements in the vector. So because vectors can expand and contract, sometimes during your program you might lose track how big it is. Well, we can get size, and look at that. Size returns the number of elements. So just thinking, size returns an integer. So if I want to loop through my vector, I don't have to know how big it is, because I can just go I equals 0, I is less than my vector dot size, parentheses. And then size will return that vector size, and our loop will just go through the whole vector. It won't go out of bounds, it won't miss any elements. We'll take a look at that example when we get going. So vector functions are neat, but we're going to start with simple. We're just going to add, subtract, and then check the size. Okay? We can also access things using the indices just like an array. Vectors also support iterators for traversal, and we'll look at that. But you can take my vector, right? My vector. I'll just do MV because I'm a horrible. You guys are tired of my scribbles. And then just like we did with our array, we can say I want to see what is in index 5. As long as your vector has 5 indexes, right? If you don't, you're going to get in trouble. So I can see out. And then my vector, and then I can pick an index. So we can do single elements on a vector just like we do an array. We'll see more of these when we see our code. We're just doing some vocab stuff. All right, what is the biggest difference between our vectors and arrays? Now, vectors and arrays, there's so much going on with vectors and arrays. We just want to kind of touch on them so you can use them a little bit. You're going to get some out of bounds errors. You're going to get some segmentation faults. But that's okay. That's what learning is all about, is writing these things and having some errors and then coming back from it. Problem solving. So the biggest thing, vectors are dynamic resizing. They're very flexible than arrays. Arrays are fixed size. Okay? They require manual memory management. I use both a lot depending on the situation. I tell new students, if they are just learning, get comfortable using an array and just limit that you're not going to be able to resize it. Okay, just plan for that. And then when you're comfortable with the idea of indexing, with the idea of traversal and all that, then move to a templatized array, which is the vector, and just now you're ready to go. You can just sail across the end of the world with that. So what we're going to do is we're going to jump over into wrong class. We're going to jump over into Visual Studio, and we're going to take a look at some of these things that we talked about on the slide, and that'll give you an opportunity to fire up your compiler and maybe try a couple of these before everything goes, before lunch or whenever you're watching this. But please practice, okay? I promise it'll help. All right, let's get over to the to Visual Studio. Hey there. Here we are, Visual Studio. We're going to go over our vectors and our arrays. So let's look at what we got going here. You see that I've declared a couple of arrays and a couple of vectors. And then I wrote some methods for us to play with so that we can see what's going to go on with our vectors and arrays. And we'll step through these one at a time and explain kind of the things that are going on. Now, remember, arrays cannot be resized. So when we declare an array, we give it a data type, a name, and then we're going to give it a size. Here, we are going to populate this array at compile time. So we're going to add 0 through 9, and that gives us 10 numbers. if we try to add any more, it's going to say we're just going to have problems because when the compiler initializes this, it's going to go out. We tell it how big it is. So numbers. Now, do we have to have 10? No, we can have less, but we just can't go over. And that's overflow out of bounds called names. And this is a string array. It can hold 2 and it can hold 3, but it cannot hold 4 items at all. And we're going to populate this one later. But this one we've populated. Now we're just going to go ahead and print our array. So our array is called numbers. Again, this is my method name, and this is my parameter. I'm in the main, so I'm calling numbers. It's going to go up here, and it's going to go to the method that I have called print array. Now, because we're passing in an integer array, we have to match that with our parameter. So back to the rules of a function, this returns nothing. It's just going to print. It's not going to do anything but print and get out. It's going to take numbers, and x is going to reference numbers. So x is going to make a reference, or it's going to look at the memory location of where numbers is. And then it's just going to loop across numbers, and it's going to print 0 through 9 because it has our for loop. I is 0, I is less than 10, so 0 to 9, increment by 1 each time. Because x is indexed, I will be x index 0, or number at index 0. So it prints out 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And those are the values that we have inside of our numbers array with a little method to print. We're going to come back and we're going to populate string names, and we're going to use reference for that, a pointer. So we're going to do that at the end. Now I did the same two things with cities. I have a vector called my vector, and that is going to hold an integer. Now when we declare vectors, we have to include vector. Pound include, which is a direction towards the preprocessor that says, go get the vector library. We're going to be using the vector library. You're like, okay, I'll go get it, C++. And then you can use the vector library. So we've declared or included our vector. And now we're going to get right here and we're going to say, okay, we're going to use the vector library. We're going to make an integer vector. Notice the carets. And then we're going to give it a name. Now this is empty. But it doesn't matter because we can fill it with however many things we want. We did the same thing right here. We said a vector. We're going to use vector. It's going to be a string vector, and it's going to be populated by cities. Now let's say that I only lived in these 3 cities, Denver, Phoenix, and Dallas, right? Well, now, okay, so it's going to be 3. Well, if I want it any bigger, I can keep adding to it no matter what. Notice it doesn't get angry like the array, because the vector can change its size. And that's really, really cool. So here when I print cities, we're going to call this method, but let's look at print cities, okay? Here is my print vector, and we're passing in a vector string, and it's going to reference foo, okay? So now cities is going to come up, and it's going to be replaced by the word foo, and we're going to run a loop, but here's what I want us to see. Vectors know how big they are. Because there's a library attached to it, there's a lot of methods that go with it. And vectors know how big they are. So the vector, we don't know how big our vector is because, again, we can add and subtract cities. Every city we go to, we could add to it. So we're just going to say foo.size, which is different than our integer array. Our integer array, we have to tell it how big it is. And we'll look at the secrets of doing that later. But the array doesn't know how big they are. But the vector does, and the vector, we can use the size. So when I print this, it's going to print whatever size, it's going to take that size and return an integer, and it's just going to run that many times. So our vector is 1, 2, 3, 4, 5 big, so 0 through 4. So we didn't have to put stop at 4, we just said stop at 5. Well, let's say I moved Atlanta and Minneapolis again. Now it's bigger. Well, did we have to change anything in our loop? No. We just get to use the stop, and it's going to go ahead and end the index. Sorry, but because it's Visual Studio and it just gets, it's just go pretty quick. I think my system's a slug, not necessarily Visual Studio. So it's just going to run all the way to the size of the vector. It's built. The build is done. It's just right now. It'll catch up. Maybe I'll go in and do some fancy editing. Get rid of this. All right, here's my terminal, and it's like, okay, so there it went ahead and printed the extra indexes and the extra data that we put into our vector. So that's pretty cool. So that's print cities. Now we have an empty vector called my vector. My vector is we are going to add to our vector, and then we're going to print it. Okay? So let's take a look at this. Oh, I did these one at a time. My fault. There we go. So now we're going to add to my vector, and we're going to pass in my vector, which is the integer vector. And so this method is going to run first, and then this method is going to run after it. Right now, my vector is empty. So when we go to add to vector, what do? Well, we're going to, this is a void because I'm not returning anything, but I'm going to pass reference. So we'll talk about this more with reference and value, pass by value, pass by reference. But we talked about this a little bit. I'm just passing the memory location. I'm saying, hey, my vector, your a vector is going to know, you got to share your memory location with a vector because I don't want to return anything. And it's going to be like, okay, I'll go to the memory location and I'll just put stuff in there, and we don't have to tell anybody. All of a sudden you go back to your memory location that was empty, and now you have value. And since we're creating the vector using the vector library, we have this awesome method called pushback. And this is how we add to a vector. We add to a vector with, they've got tons of methods in vectors. So a vector is going to push back I. And what is I? I is going to be 0 through 9. So it's going to add 0 through 9. And then when we're done with this method, we're going to go to print my vector. And again, look, my vector size is going to print however big my vector is created. So this, we'll go ahead and make a vector, and then it'll print 0 through 9. Okay? So that's pretty cool because we created the vector and we built the vector. So we use the method, add to my vector that took the vector and went up and it got the reference, got the memory address, and then it ran a loop and used the method inside the vector library, pushback, to add to the vector. So when you have a vector, you can make it empty and then just add to it anytime you want. And then I just went and printed it with index. Well, here we have my vector, which is this guy, same thing that we created, right? It's going to populate itself, it's going to print it. And then we are going to show you how to return a vector. So we're going to return a vector in our method, and it's going to put it back into my vector. And then look, see, this method is the exact same as that method. So this will print 0 through 9, and this will print whatever changes we made to my vector. And this is just how we index sometimes. So when I return a vector, all I do is the same rules as we did with anything in our functions, data type. We are going to return a vector. So we say, okay, it's not void, it's not integer, it's not anything else. We're just going to return the vector. And then we make a new vector called in my return. We pass reference to my vector, and then what do? We take my return at index 4 and we give it a number that we can recognize, 10,000. And then we return the vector that we just mutated. Okay? Because we can return it because it's here. So now we've populated with 10, we printed it, we're going to change it, and then we're going to print it again. And notice we're only changing one value, and we're printing the same vector twice. Okay? Exact same vector. So we're only dealing with my vector. So what is this going to do for us? All right, it prints out my vector. Look, we went and we used the index 4 to change the number 4, right? Index 5, 0, 1, 2, or 1, 2, 3, 4, 5. To change that value to 10,000. So instead of pushback, we can change values in a vector using the index once it started and populated. And that's pretty cool. And remember when I said vectors are stupid? Or vectors are smart and arrays are stupid? Because arrays don't know. Take a look at how we deal with this. Remember my vector that we created? It's going to give us size and element. Okay? Every time we there we go. We have to add to the vector before we do anything, because since we stopped the program, it clears all the memory out and it would be 0. So now tell us the size of the vector size and elements. If we try and use the size of for our numbers array, remember our numbers array up here, our numbers, we know the size is 10. If you think size of, that's going to give you the size in bytes. And because we know that integers are allocated at 4 bytes per integer on your 32-bit machines, you are going to get 40. So it's going to be size 40. But how do I find the size of it? Well, I can take the size of divided by the size of my very first index. So size of, so let's take a look at what happens here. This just explains that you can't use the size of to use a loop for an array. It'll get angry with you. So again, the vector populated, the vector has 10 elements. The size of the vector is 40 in bytes, and then 10 is the array size in elements. And how did we get 10? 40 divided by 4 equals 10. So 40 divided by 4 bytes. And the number 0 is an integer, so that's 4. 4 divided by 40 is 10. So those are arrays and vectors, but there's one more thing we want to look at, okay? One more thing we want to look at. Oh, don't do this to me. One more thing, and that is this thing right here. Return array pointer. You cannot return an array like you can return a vector. See this? Arrays can only return a pointer of the data type. So we are going to add to our array, our string array. We know it's size 3, and we're going to put Chester, Charlie, and Leo, and then we're going to return a pointer. More on this later, but I just want to see what we have. So we're going to call this, right? And it's going to return that string pointer, and then we're going to print the names. Okay. Even though we return the pointer, we're just going to go back up and print names. Because we just did it. And then you're going to get the name studio. You make everything so mean. Chester, Charlie, and Leo. Okay. That is a short thing on vectors and arrays. They are beautiful, beautiful data structures. You need to practice vectors and arrays. So go ahead, now that you know how to initialize a vector or an array, build an array, populate it, run a loop on it, print it out. Okay. build a vector, include vector, build a vector, use pushback, and then print it out. So play with these things with the stuff that we've already done. We've done data types, we've done conditionals, we've done build an array of 0 through 9 and come up on your print statement and then go through it and run an if inside of your loop. If I mod 2, right? We're only going to print out even ones, or let's print out odd ones. Is the same as 1, then just print out thing. So now we just print out odd numbers, right? So now we're just going to print out odd numbers. So then numbers, what's that going to do? That print are just give us odd numbers. So you can use conditionals in your array, but just give yourself a few minutes, type a few of these out, just so you've at least done it before you start class, and your teacher will be like, you're the smartest person here. Look, odd numbers, 1, 3, 5, 7, and 9. Chester, Charlie, Leo. Array size. Why not? Make an array size 100. Run a loop and populate it with 100 numbers. Do that with a vector. All that stuff. Okay? When we next video is going to be passed by reference and value, kind of pointers and address of stuff. And then we're going to get into classes, and then we're going to build our first application. All right, you're awesome. Bye.